All right, in this second video, so in the first one you should have written this information down. If you haven't, you can write it down now. You might not have needed to watch the first video. Let's move on to looking at some examples. So representing inequalities on a number line. Okay, so we looked at that previously. So a number line, okay, we can see number lines here. When you're doing your number line, you don't always have to start at 0, and you can see that here they haven't started at 0. Always think about, well, what's the number in the inequation? So for the first one, it's 4. Sorry, I shouldn't use that. I keep forgetting to use my pencil. Okay, so this one is 4. So obviously on your number line, you need to have 4. So I would, and I'm sorry, it's not just a very straight line. You would have your line and then the number 4. And then I would just put a number either side of that, 3 and 5. And you don't really need to go any further. You can see in this solution it's gone up to 6, but I can clearly indicate by this number line, okay, what the inequality is. So x is greater than 4, or equal to 4. Now, the first step is just drawing your circle. And because this is equal to, we've got to have a solid circle or a closed circle. Now we want numbers that are greater than 4. So if you're ever unsure, think, well, x has to be greater than 4. What is a number greater than 4? Or what is the next number greater than 4? It's 5. So we want to go in the direction of the 5. And there's your number line. Okay, let's move on to the second one. So this time we're looking at the number 6. And I know the solutions are there, but this is how you can quickly do it. Okay, so put your 6 down and then a number either side. So we've got a 5 and a 7. And it's a good idea to put your arrows on to indicate that they keep going. This time we've got x is less than 6. So at 6, I'm going to draw my circle, and it's an open circle because we're not including the 6. Okay, so this open circle means that we're not including the 6. Now, x has to be less than 6. So think of a number that is less than 6. Well, 5 on my number line is less than 6, not 7. So there's your answer, and you can see there that they've gone from 3 to 7. You don't have to do that. You can just do 3 numbers and you still get the same answer. All right, last one. This time we're going between 2 numbers. So this means that x is greater than 1, but less than or equal to 5. So draw your line first. Now we want to include 1 and 5. So I'm going to do a number either side of them, so 0, and I'll put the 6 here as well. And then we've got to do 2, 3, 4 in the middle. 2, 3, 4. Not very even, but that's okay. Let's put the arrows on the end to indicate that it keeps going. All right, so the x has to be greater than 1. So we'll do an open circle there. And x has to be less than or equal to 5. So I do my circle at 5, but this time I shade it in. And this basically means x is between those 2 numbers. So I'll just draw a line going across like that. And you can see the solution there as well. Okay, so let's have a look at some real life situations. So describe the inequality for each of these. So Fred is shorter than 160. Okay, so if Fred represents x, he has to be less than 160. John is at least as old as Maria, who is 10. So this means at least. Okay, so he can be 10 or he could be older. That's why it's greater than or equal to. Rose's test score is between 40 and 50 inclusive. So this inclusive means you include the 40 and 50. So that's why we've got a greater than or equal to and a greater than less than or equal to and less than or equal to. But the way you would read this is you would always say the x first. So x is greater than or equal to 40 and x is less than or equal to 50. So you can actually separate this into 2 if you wanted to. So this would be good to put into your bound reference as well. in addition to these words. Okay, so perhaps having them down, because this is new language to you, that you might come across a question that says at least, and you're not sure, does it include or doesn't it include? Inclusive, does it include, doesn't it include, stuff like that. Okay, so let's go to the key ideas. So given an inequality, an equivalent inequality can be obtained. So this is basically solving inequations. So you can see before we only had the pronumeral, not anything else, no other terms, but these ones can be solved. Now the inequations are solved the same way as inequations are. Okay, so you can see that in the first one and the second one, just the first one, not the second one, I just realized. The first one is solved the same way as a normal equation. Now, the second and the third one are slightly different. You can see here the sign is reversed. The reason for that is because, and this rule here, is it? Oh yeah, it's written in here. Okay. This one here is important. Okay, so I'm going to put a little star there. It might be a good idea to put these two examples there. When you multiply or divide by a negative number, your inequality changes direction. Okay, so you can see here that we've divided by -4. Okay, so the inequality has changed direction. For this one here, let me just think, what have they done? Okay, so we switched the x and the 1. Okay, so that's what this one means. Okay, so we've switched the x from the right-hand side to the left-hand side. So the crocodile is still eating the 1. Okay, the crocodile is just facing the other direction. So your key ideas, these key ideas should also go into your bound reference. All right, solving inequations. As I said before, you should be treating these just like normal equations unless you come across a negative sign. So I think you should have a go at doing A and B because there's no negatives involved. But when you get to C, okay, and I can see here that this negative here will mean that this inequality sign will change direction. So perhaps pause here before I give you the solution to see how you go. All right, so the solution, okay, you can see for A, okay, you solve them just as you would a normal equation. Your inequation stays the same. Okay, so it's less than all the way. B, okay, hasn't changed direction, but in C, because we divided by a -2 here, it changed from a greater than to a less than. All right, so work through question 1. Remember drawing a number line, so your easiest thing first, and I'll do letter A for you first. So we've got x is greater than 3. Draw your number line, put 3 in, 2 and 4, and it's at the number 3, and because it's greater than, it's an open circle. X is greater than, so think of a number greater than 3. 4 is greater than 3. Draw your line. Okay, so I can hear my son coming home, so I might leave this video here and create another one later for the following examples.